Okay, so welcome to this lecture on data distribution. We already started this topic last week, and last week we discussed about natural normal distribution. In our previous lecture, we talked about what is dispersion, what is normal distribution. Normal distribution is also called Gaussian distribution, and what is variability of data distribution. And we also talked about what is mean and what is standard deviation. Okay, so we did talk about dispersion, distribution. Then we took this example where we considered some student, 20 students, and we considered age of each student, and then we analyzed the distribution of different ages. Okay, you might already remember what is frequency of data. Do you remember? Okay, and we computed mean and median of this data, and then we computed histogram, and in this histogram we saw that we got this bell-shaped curve from the data distribution. Okay, and then we discussed some characteristic of this curve, and we said that it is a bell-shaped curve which is symmetrical about the mean. Okay, and then we said that for normal distribution the mean, median and mode are equal. Okay, now we talk about different examples in day-to-day life where the data is distributed normally. Do you think that height of different people, the value for height is distributed normally? Yes or no?
Yes, sir.
Okay. Okay. Can anyone explain how it is distributed normally?
Because the normal value of the human body is 5 to 6.
5 to 6. Okay. And then?
So age is also minus.
Again?
Children greater than 2 years of height.
Did you understand something? No? Okay. Sorry, but no one understood anything. So, what do you mean?
Sir, I mean that the age depends on the height depends on ages. Small children have.
Yeah, but is this correct that height depends on age?
The statement is almost right.
Yeah.
There is no
Up to some extent, there should be some.
Think about children.
Yeah. Yeah, this is a very interesting point. Up to some extent, height depends on age, but then
sometimes it is not.
in some
Because
cases.
Sir,
So,
I'm
Yeah.
talking about children.
yeah. Okay. So it's not totally dependent on age, but up to some extent. Okay. And but the question is not this, that whether height is depend on age or not, but whether height, the value for height is distributed normally. Okay, whether the value for height is distributed normally, and the answer is yes. Is there anyone who is not agree with this statement that the height of different people is distributed normally?
So if we take the example of tree.
1 minute.
Yes.
What about you? Do you understand what is normal distribution?
Sir, first class.
It's your first class. Okay. Do you understand this normal distribution? Okay. So you just need to revise our previous talk and then you will understand what is normal or Gaussian distribution. Okay. I think this class will not be too much helpful for you if you don't understand the previous contents, but we have recording so you can just go through the previous lecture and then you will understand. And by the way, why it is your first class? Because it's or theoretically it's our fourth class. So okay, no problem. What about weight?
Sir, your answer depends on age. Sir, for
Weight
children.
for children. Okay. Yeah, but why you are linking these two variables? We are actually interested in the distribution and not the dependency. Okay, so why this question comes in your mind that whether height is depending on age or not or weight? Why it is so?
Sir,
Is there any?
sir, every day I'm dealing with these things. That's why.
Okay, okay. Shoe size, of course. Okay. Do you see any importance of these information, whether something is distributed normally or no, or how the data is distributed? Is there any practical significance? If there is any practical importance, or this is just like I am taking class, I am teaching you, and you come to class and you look at these slides and you go back. So, what's the practical significance if we know about?
Explain this final example. For example, the size of the shoe.
Yeah.
So if the company is making different types of shoes, if the company knows that normally the shoe size of any individual is in the range of this and this,
Yeah.
so it will automatically produce shoes in that range,
Okay.
and not the extreme, for example, of size.
Yeah. Okay. Right. The rest, I think you have understood it correctly. But why it's important to know the distribution of data in some area? Okay. Did you understand about these shoes problem? Okay. If the company knows about the mean value and about the extreme points, then they will manufacture these items according to that range. Okay, they will manufacture size, more number of shoes with mean size and less number of shoes with extreme values, and then it will ensure that all the shoes will sell. Otherwise, if like they manufacture the shoes with uniform size, then the chances are that the mean values will be sold soon, but they can get the extreme values or the outliers back. Okay, so this is shoes case. What can be another example?
Sir, same is the example of clothes, ready-made clothes.
Yeah, exactly. What can be another example where these information can help us a lot?
We can also use the weight and height in different sports activities, like weightlifting,
Yeah.
or some boxing. So it will depend on the weight of the participant. If he or she weight is 80 pounds or something, then they will put in one category.
Yeah.
And if the weight is 70, they will put in the second category and so on. And then they will be competition to be
Yeah, but what's the point here about this distribution? In a sense,
The
point.
equipments, you want
Correct.
to explain that the equipments coming for them for the competition,
Yeah.
then these equipment devices.
Yeah, then that would make sense. If like majority of the participants are with some specific weight category, then more instruments should be in that range. Yeah. Any another example?
If you are talking about the size of the laptop,
Uh-huh.
It can be also.
How?
Now, for example, normal people like the screen of 14-inch,
Yeah.
14 to 15.
Yes.
So if they go to the extreme values,
Yeah.
people will get.
Yeah. Yeah. Correct. Okay. I hope some of you have understood this concept. I'm not sure about the whole class, but some of you. Exam marks. Is there any significance if we know that the marks is distributed in this range and then the mean range is this one? Okay, I think it would be a bit difficult, but
Usually the results are not distributed normally.
Really?
The expectations from the students. But when the evaluator makes the paper,
yeah.
he may have distributed the number on the paper.
Okay, this is interesting, Raif. What do you think when the students get these marks? So are these distributed normally, or I mean that the examiners they don't distribute marks normally, but whether the students get values with normal distribution or no?
So it depends upon the students are how intelligent distributed or
Okay. Okay.
this is
And again, the next question is whether the intelligence level is distributed normally among. No.
Sir, a majority of the student intelligence level is belong to the mid level.
Okay, now there is. I have the feeling that there is the concept of this normal distribution is not conveyed well. You have some problem in understanding this concept. The intelligence is not distributed normally, but the fact that most of the people are not top intelligent, they have average intelligence. There are few people who are top intelligent, there are few people who are okay. I don't want to use this word, who are not that intelligent. You understand? Okay, I think that like most of the people they have. Okay, these are such statements which I myself I am not agree with like such stuffs. But let's say let's take the common phenomena. Most of the people they have average intelligence. Okay, and then there are few people who are less intelligent, okay, and then there are few people who are top intelligent, and then there are very few people who are genius, and then there are too few people who are. Is there any category about genius?
extra genius.
Extra, okay, we can say extra genius, okay, and then on this side there are like poor students and so on, and so this is my feeling that this curve like this one, I'm not sure. What do you think? It should. What? Do you want to say something? Bell shape, yeah. Okay, so and if the intelligence is normally distributed, then the marks obtained should be also normally distributed. Okay, because marks are okay. We are talking about data analysis, but does marks obtained has some relation with intelligence or no?
Yes.
Yes, sir. Then there also comes other parameters like hard work. two people with the same intelligence level can get different marks, but in any case, like normally intelligence have some relation with marks obtained. Okay. I heard that when you said intelligence is not distributed normally. Did you say this or no?
He says
No?
that
It's related to intelligence.
Okay.
He
Is
said
there anyone who says that intelligence is not distributed normally?
I have said and I am convinced right now, so I will.
Okay, you take your statement back. Okay. Good. Variation or spread of distribution. So, like how much the data is distributed. We say that average value is this one. Then, how much the data is distributed? What are the extreme points? What are the outliers? Okay. So then we have another term that is called range, in which to range the data is distributed. What is the extreme on one side? What is the extreme on another side? And then standard deviation is like some average extremes. Okay, one is okay. Let's go through this and then you will understand. Range is maximum score minus minimum score is equal to range. What's the range of the distribution? So you take the extreme low value, the lowest value, and the largest value, and then you just take the difference, and that is your range. It's a crude indication of the spread of the score. So from this range, we can understand the extreme values. Okay, and then the important or interesting value is standard deviation, and in range you know about the extreme points, but in range you know that what is inside these two extreme. Like you take some slots between these extreme points and you say that this amount of data comes in this range, and then this next number of data come in the second range. Let's say that the extreme are 1 and 10. Okay, there are two extremes. Let's say 1 and 10. Then the question is how much values are in between 1 and 5, and how much values are in between 5 and 7, and how much values are in between 5 and 9. Okay, so these are the information of inside of the data. From range, you get the extreme points, but from deviation, you know about the distribution inside these two extreme points. Do you understand? Okay. For example, when I say that range, the one extreme is 1 and the other extreme is 10, then how many samples have value 1? Okay, and how many samples have values between 1 and 3. So these information, I cannot get these information from the range, because I said that the range is 9, 10 minus 1, 9. But then how many values come in the inside 7 and 8 or 7 and 9. So these informations are obtained from standard deviation, and these are also important. Okay, because when you say that the range is 9 or like from 1 to 10, and then you manufacture some item uniformly and the range is 1 to 10, so it will not be a good managerial decision, because we don't know that how many samples of population comes in the range of 1 and 3 or 5 and 7 and so on. So for this you need this standard deviation. Okay, because then it will give you an informed decision about manufacturing.
Yes, sir.
Clear? Okay. Okay, this is to some extent an important calculations. There are, I hope, 5 samples one sample has value 10, second sample has value 20, 30, 40, 50. There are 5 samples. It can be for anything, that is not an important point. We are interested in some computation. So deviation is equal to the sample value minus the average or the mean value. So for 10, 20, 30, 40, 50, the mean is 30. Correct or no? What is the mean for 10, 20, 30, 40, 50? The mean is 30. And then the deviation is sample value minus mean. So we get deviation as minus 20, minus 10, 0, 10, 20. Is it clear or no? Clear. Okay, and then absolute deviation, you just take like you discard the symbols and you take absolute values. If the deviation is minus 20, then absolute deviation is 20. Okay. And then square deviation. So deviation is x minus mean, and square deviation is x minus mean square, whole square. Okay. And then we get 400, 100, 0, 100, 400. Okay. And then mean for this square deviation is 200. Okay. And this is also called variance. This average square deviation is also called variance. And then standard deviation is equal to, when you take roots of variance, then you get standard deviation. Okay.
Variance means x minus mean square.
X minus mean square, whole square. Okay. But then average of this, because x minus mean square will be for every sample, and then when you take the mean of this value, then you get variance. Okay. And standard deviation is when you take roots of this variance. Okay. Now we don't need to prove these formulas because we are not in the class of statistics. We are analyzing data, so we just have to accept these formulas, because this is the job of the statistician, that why standard deviation is equal to this and why variance is, what's the logic that like taking mean of this standard deviation is a good criteria to know about the variance. So this is, I think that this is beyond the scope of this class. We are analyzing data and we are not defining parameters for analyzing data. Okay. So this formula like standard deviation, this is quite important, and you should understand this at this moment, that when you take variance of data and then when you take root of this variance, then it gives you the value for standard deviation. Okay. And then why why we use standard deviation? So it is used as a measure for spread when mean is equal to center. Okay, when you draw this on a 2D plot and when you put the mean on the center, so you use this standard deviation, and units for this standard deviation is the same as the unit of your data. Okay. And
They will create more than one standard deviations in a range in a single range.
No. In a given sample, there will be only one standard deviation. Okay. There shouldn't be more than one standard deviation. Okay, and there will be only one mean. Yeah, and there will be only one standard deviation.
So if you said that, for example, we have values in the range of 1 to 10.
Mm-hmm.
So now we conclude that how number of occurrences of the sample in the range of 1 to 3,
Yeah.
and how number of occurrences in the range of
Yeah,
2
but
to 7.
for standard deviation, you will consider the given value. The range is 1 to 10. You will be having some samples. Okay, you will take the mean and then the variance, and you will always get a single mean variance value. Okay, there shouldn't be more than one standard deviation. Okay, still confused or no? But you are not confused, but you are not convinced. Am I right?
Yes.
Okay. And what about the rest? I can talk to you later, but if others are also not convinced, then we can talk now.
There's some confusion about the deviation.
Okay, there is some confusion in what?
Deviation.
Okay, deviation. So we just go through there. Some examples are coming, and I hope that with those examples, I hope this point will be clear. Okay. Now I said that S or standard deviation is always positive. So since we take absolute values, we already discard these symbols. So in any case, we will get positive value for standard deviation. Okay, and then higher S is equal to more spread. If in two samples from a same population or different population, if the standard deviation is more, then it means that the data spread is more. Okay, and if the standard deviation has smaller value, then it means that the data is compact. There are many values with similar there are many samples with similar values. But if the standard deviation is higher, then this means that there are values which are too different from each other. Again, you will see this in coming examples. Okay, S is equal to 0. If the standard deviation is 0, then this means all values are equal. There is no spread. And standard deviation is affected by outliers. Outliers are the extreme values. So in median and mode, we said that these values are not affected by the outliers, but the standard deviation is affected by outliers. Okay. We will see this slide back and we go next to our example, and then we will come to this slide. Okay, now it's a curve for now you should know about another term that is called Gaussian or Gaussian distribution. Have you heard about this?
Gaussian.
So Gaussian or Gaussian. Okay. Anyhow, so this normal distribution and Gaussian distribution, these are the same wording, the different wording for same concept. Okay, and especially in image processing, you will listen this term Gaussian distribution. There, it is referred as Gaussian distribution, but in data analysis, it is referred as normal distribution. Okay, so here mean is 50 and standard deviation is 15. Okay. So this is the mean value, and this is one standard deviation. Okay, now this is important. Okay, now this is your midpoint. Okay, 50 values should be on 50% values of the sample should be on one side, and 50% values should be on the other side of this line. Okay, like this curve, it gives you the complete 100% values. Then we are interested to know that how much percent of the given samples come in this range. Okay, and then how much numbers of samples comes in this range or in this range. Okay, now these are some important points. So you should know that under this normal curve, 50% values are on one side of the mean value and 50% values are on the other side of the mean values. Okay, there will also be some mean values. Okay, if there are 100 samples and if there are, let's say that the mean is 20 and there are 10 values with mean, then the remaining values, there are 90 values. Okay, so the 45 values will be, I think I confuse these figures. If there are 100 samples and the mean is 20 and there are 10 samples with this mean values, then the remaining values are 80. Okay, so in these 80, 40 will be on one side and 40 will be on second side. And then, okay, now this is one deviation. This is the mean point, and this number, this is one deviation. So from this value to this value, 35% values should come in this range. Okay, and then 14% values should come between the first mean and the second mean value. Okay, and then there should be, let's say, 2%, around about 2% values, and again 34% values should be on the left side in first mean category, and 14% values between first and second mean, and 2%. So it becomes how much? 68, 28, and 4 from what? 100. Huh? 100. 16, 34, 50. So 50% are on the right side, 50%, and 50% are on the left side. Okay. Is there any question? Because this is important.
There may be two standard deviations, one on the left side and on the right side.
There is only one. Okay, interesting. When I said between first standard deviation and second standard deviation, so it is in a sense contradiction to your point when you said there are, whether there are more deviation or one deviation, and here I said between first deviation and between second deviation. So there is no contradiction.
No, sir, deviation will be there in a single range, more than one deviation, but standard deviation should be one.
Yeah, okay. Now this is 50 and here it's 65. So the standard deviation is, okay, it's 15, yeah, it's already here. Okay, so when I say that first deviation means that from 50 to so from 50 to 65, this is the first deviation, and then from 65 to 80, it's the second deviation, and then from 80 to 95, it's the third deviation. So I said 3 deviation, but the value is same. Okay, so these are not different deviation. This is the same one value, 15, but from 50 to 65, we say that this is the first deviation, and then from 65 to 80, it's the second distribution, and from 80 to 95, it's the third deviation or standard deviation. And similarly on the left side, okay, so from 50 to 35, it's first deviation, and from 35 to 20, it's second deviation, and from 20 to 5, it's third deviation. Okay, so in this first deviation range, like from when we take 50 as the 0 or the mean value, then 68% values should come in this range. Okay, it should come between 35 and how much? 65. 68% values should come in this first deviation from left and right, and then from this point to this point, it's 14 and 14, 28, 28 and 68. How much? 95 or 96? Okay, so 96% values should come in this range. Okay, 65% values of the whole samples should come in this range, and then 2% values of the samples will come in this range, and 2% values will come in this range, and then 100% values will be under this curve. Is it clear? It should clear. And now we go back to our previous slide. Okay, standard deviation, a measure of dispersion around the mean calculated so that approximately 68% of the cases will lie within plus or minus 1 standard deviation. Okay, and 95% within 2 standard deviation, and 99.9 or 100% values should come within the 3rd standard deviation on both sides of the mean. Clear? And this is often referred as 68, 95 and 99 rule. 68 means that 68% values come in the range of first deviation, and then 95% values of the whole samples come in this under the second mean, and then 100% values comes in the third mean. Okay, and these information will give an informed decision, because then, like the manufacturer, they can prepare let's say 4% items with mean with third deviation, and 95% values which should come in the range of second deviation, and 68% values should come in the first deviation range. So these are very interesting information, and it gives some manager good credit, because if all the items which are manufactured are sold out, then it means that the decision was quite good. Okay, is there any question? Oh, I just forgot and continued clicking. Okay, so usually you consider mean as 0, and in our case the mean is 50, but this is considered as 0, and then 65 is considered as plus 1. So it is 1 deviation and minus 1, 50 to 35, it's minus 1 deviation. So these are just like assigning code, whether you call it 50 or 0. If you call it 0, then 35 is minus 1 if the standard deviation is 15. Clear? Okay.
So then what does this standard deviation value tells us? The standard deviation value is 15.
15. This is like the average difference between the mean value and the deviated value, the average difference.
This is once again the average of the deviated value.
Yes. Okay. Now we have 3 curves, 3 distributions: school A, school B, school C, and let's take it as intelligence value. You can assign it any values, but let's take that this distribution shows the intelligence values of 3 schools. And one school the mean is 50, and in second school it's 60, and in third school the mean is 70, and then the standard deviation is 10, 10 and 10. Okay, so for all these 3 schools, as the deviation is same, okay, So we get similar curves. But if the deviation is different, then we will get different curves. So here we see that although the mean is same, the mean is different but the deviation is same, so it means that the data spread, the range, this is same. Okay? And now here the mean is same but the deviation is different. Okay? So the school with deviation 16, the curve is this blue curve where the data distribution range is larger as compared to the red curve, and this standard deviation shows us the distribution of values. It means that in this first school the values are close to each other. There is not too much variation or too much distribution or too much scatteredness inside the data, but for school C the data is scattered too much. Okay. Now, for example, there is a class and I want to know the intelligence level, and I want to prepare my lecture according to the intelligence level of the students. So if the deviation is larger, then I will face some difficulty in preparing my lecture because I will have to consider a variety of intelligence level. But if the deviation is smaller, then it will be easy for me to prepare the lecture because I will know that okay, all students have the same intelligence level. Okay? So the same information can helpful in some other decision making activities like assigning, making groups in the school or making classes in the school. Okay? So when you have like distribution with smaller standard deviation, it is a good decision to put these samples in one group. Okay? You had some question, you said that there is some confusion. Is it clear now? Okay, good. Okay, so this is Sam, you should already know about this. Okay. This is an example, and I hope now you should be able to compute these different parameters, like what's the mean of this value and whether the data is distributed normally. And if yes, what is the standard deviation. So I give you this as assignment and you can work on it and analyze this statistically. The point is whether women study more than men, and then there are some random samples of 30 women and 30 men. Okay, and these values are like number of minutes studied per night. Okay, so you can analyze this and then come to some conclusion whether women study more or men. Okay?
Mean value for men is 75, 175, and
okay.
women is 120.
Okay. I don't want to work it out here, but you can just do it at home. Okay, and we will stop here. Thanks.